Finds the coordinates of the points on the curve y equals 1/3 x cubed plus 9 over x, at which the tangent is parallel to the line y equals 8x plus 3. So parallel to y equals 8x plus 3, that's telling me that the gradient is going to be 8. So when is the tangent to the curve, when does that tangent to the curve have a gradient of 8? So let's find the gradient function and make it equal to 8. So I need to differentiate this. In order to differentiate this, I first need to write it in index form, like this. I can now differentiate this to get the gradient function. So 3 times 1/3 will just be 1. 3 take away 1 is 2. The minus 1 times 9 is minus 9. The minus 1 take away 1 is minus 2. So this is my gradient function. This is the equation that tells me what the gradient is going to be. And I know that the gradient needs to be 8. I want to find the x values when that's the case. So I want to solve this equation. Now, the way it's written at the moment, I don't like the fact I've got this minus 2 power here. That's good for differentiation, but when it comes to solving equations, I don't like that. So let me rewrite that like this. Excuse me. Right, now by writing it like that, I can see quite obviously my next step is going to have to be to multiply through by x squared. I don't want that x squared on the denominator, so I'm going to times each term here by x squared. So x squared times x squared is x to the power 4. The 9 over x squared times x squared is just going to be 9, and the 8 times x squared will be 8x squared. Put everything to one side of the equation. And I now have an equation to solve. I'm going to do this with a substitution. I'm going to say let t equal x squared. That way, t squared would be the x to the power 4. So I would have t squared minus 8t minus 9 equals 0. Factorise. And find the solution. So t is equal to 9 or t is equal to minus 1. Then just remember what t was, because that was just a parameter that I made up. T was equal to x squared. So let's swap that back. So x squared is 9, or x squared is minus 1. So square rooting, the square root of 9 is either 3 or minus 3. The square root of minus 1, well, there's no real solutions for that, so I don't need to worry about that. So I know that x is either 3 or minus 3. I just need to know what the y coordinates would be now at those points. I know that the gradient when x is 3. I know that when x is 3, the gradient is 8. Therefore, it's going to be parallel to y equals 8x plus 3. I just need to know the y coordinates at that point. So I'm going to substitute that x back into the y equals 1/3 x cubed plus 9 over x. So 1/3 times 3 cubed plus 9 over 3. So that's 9. Plus 3, so that's going to be 12. And we can do a similar thing for the minus 3 now. So that's going to be minus 9 minus 3, so that's going to be minus 12. So these are the two coordinates where the tangent is parallel to the line y equals 8x plus 3.